Hello everyone, you're welcome to solve this nice algebra problem, which is 4 to power t plus 3 to power t. This is equal to 91. So what is the value of t? And given that t is greater than 0 and that t is a member of positive integers. Now solution from here, we can express 4 to power t as 4 to power t raised to power 1. This is the same thing. Then plus 3 to power t raised to power 1. This is equal to 91. So 4 to power t raised to power 1 is the same thing as 4 to power t, and 3 to power t raised to power 1 is the same thing as 3 to power t. The next step is that we can express 1 as 1 over 3 times 3. 1 over 3 times 3 is the same thing as 1. So let's substitute here. So we'll have 4 to power t raised to power 1 over 3 times 3, then plus 3 to power t raised to power 1 over 3 times 3, then this is equal to 91. So given that a to power n times m, this can be expressed as a to power n raised to power m. So here we can express this as 4 to power t over 3 raised to power 3, then plus 3 to power t over 3 raised to power 3. This is equal to 91. The next step, we can just say let x be equal to 4 to power t over 3 and y be equal to 3 to power t over 3. So substituting here with x and substituting 3 to power t over 3 with y, then here this is x to power 3 plus y to power 3. This is equal to 91. And given that x, y, these are members of positive integers, and that x is greater than 0, and that y is also greater than 0. So this implies that we have that x to power 3 plus y to power 3, which is equal to 91. This is actually the sum of two cubes expressed as a to power 3 plus b to power 3, which we can express as a plus b, a squared, subtract a times b plus b squared. Applying this property, then here we have x plus y. Then here we have x to power 2, subtract x times y, then plus y squared. This is equal to 91. Now, from these steps here, we find that x squared minus xy plus y squared, this is greater than x plus y. So this condition is very critical. So the next step from here, let's get the prime factors. Let's get the prime factors of 91. The prime factors of 91. Now the prime factors of 91, we have 1 times 91. We have 91 times 1. Then we have 7 multiplied by 13, and we have 13 times 7. And given that x plus y is less than x squared minus xy plus y squared, then you find that this is actually case 1. This satisfies the 1 times 91 satisfies this condition. Okay, 1 times 91 satisfies this condition, but 91 times 1, this does not satisfy the condition. 7 times 13, this satisfies the condition, but 13 times 7 does not satisfy the condition. So we have, this is case 1 here, and this is case 2. So let's start with case 1. Let's start with case 1 here. So we have x plus y, x squared, subtract xy plus y to power 2. This is equal to 1 times 91. So this implies that x plus y, this is equal to 1, and that x squared minus xy plus y squared, this is equal to 91. So from what we have here, that is x plus y, which is equal to 1, we can square both signs here. We can square both signs, and you find that x plus y squared, this is in the form of a plus b squared, which is a squared plus b squared plus 2 times ab. So applying this algebraic identity, then here we have x squared plus y squared plus 2xy. This is equal to 1. So let's add this first equation here with the second equation. So we have x squared minus xy plus y squared. This is equal to 91. And we have that x squared plus 2xy plus y squared. This is equal to 1. Now let's subtract these two system of linear equations here. That is x squared minus x squared. This is 0. Minus xy minus plus 2xy. This is minus 3xy. Then y squared minus y squared. This simplifies, so this is 0. And this is equal to 91 minus 1. This is equal to 90. So we have minus 3xy. This is equal to 90. So let's divide here by negative 3 by negative 3. So this implies that xy, this is equal to minus 30. And given that x is greater than 0 and y is greater than 0, then xy, which is minus, this is actually minus 30. This does not satisfy this condition, and therefore this part is rejected. This part is rejected. So let's proceed to case 2 now. Let's proceed to case 2. So case 2 here, we have x plus y multiplying by x squared minus xy plus y squared. This is equal to 7 times 13. So we have that x plus y, this is equal to 7. You can call this equation 1. And then we have that x squared minus xy plus y squared. This is equal to 13. So from this equation 1, this is equation 2. From this equation 1, we can square both signs here. This is equal to 7 squared. So this is actually in the form of a plus b squared, which we can express as a squared plus b squared plus 2 times ab. So in this case, we have x squared plus 2xy plus y squared. Now this is equal to 7 squared, which is 49. So let's sum equation 2 and this. Let's call this equation 3. So equation 2 and 3. Let's subtract them. We have x squared minus xy plus y squared. This is equal to 13. So we also have x squared here plus 2xy plus y squared. This is equal to 49. So let's subtract these two system of linear equations. So x squared minus x squared, this is 0. Then minus xy minus, that is plus 2xy, this is minus 3xy. Then y squared minus y squared, this is equal to 0. And then we have that 13 minus 49, and this is equal to 36. So this is minus 36. So we have minus 3xy. This is equal to minus 36. So let's divide both sides by negative 3, and also here by negative 3. So let's simplify here. So xy is equal to 12. Xy is equal to 12. Now from equation 1, which is x plus y, this is equal to 7. Let's make y to be the subject of the formula. Let's make y to be the subject of the formula. That's y will be equal to 7 minus x. Let's substitute this here, so that now we have x times y, which is 7 minus x. This is equal to 12. So here we have x times 7, this is 7x minus x squared. This is equal to 12. Let's take 12 on the left-hand side, so that here we have 7x minus x squared minus 12. This is equal to 0. So this implies that here we have minus x squared plus 7x minus 12. This is equal to 0. The next step is to multiply both sides by negative 1. So minus 1 times minus x squared, this is x squared. Then plus 7x times minus 1, this is minus 7x. Then minus 12 times minus 1, this is plus 12. This is equal to 0. Now we can apply the factorization method here. We have that the product is equal to 12. The sum here is equal to minus 7. So let's get those two factors. These two factors, it's equal to negative 4 and negative 3. These are the two factors. Now let's substitute this. We'll have x to power 2 minus 4x minus 3x plus 12. This is equal to 0. So from this part here and this part here, x is common here. We can factor out x. So we'll have x into the parentheses, x minus 4, then minus, from this part here, 3 is common. We can factor out 3, so that we'll have here x minus 4. This is equal to 0. So we have here x minus 4 is common here. So we can factor out x minus 4. Then here we have x minus 3. This is equal to 0. So we have two parts here. The first part is x minus 4. This is equal to 0. The second part is x minus 3. This is equal to 0. So that now the first value of x here, that is x1, is equal to 4. And we have that x2 here is equal to 3. So let's solve for the corresponding values of y. Now, if you recall here, we have that y is equal to 7 minus x. So let's substitute first of all the first value of y, that is y1 will be equal to 7 minus x1, which is 4. And this implies that y1 is equal to 3. So x1, comma y1, this is equal to 4 and 3. So this is the first set of solution. We have that y2 will be equal to 7 minus x2. So that means that y2 is equal to 7 minus x2. x2 is equal to 3. so minus 3. And this implies that y2 is equal to 4. Therefore, the second set of solution here, x2, y2, this is equal to, this is 3, 4. So this is the second set of solution. Okay? Now, from here, if you recall, to solve for the value of t, here, we are saying that let, if you remember here, we are saying that let x be equal to 4 to power t over 3 and y be equal to 3 to power t over 3. So we have that x is equal to 4 to power t over 3 and y equal to 3 to power t over 3. So let's substitute from the first set of solution here, that is x1, y1, which is 4, 3. Let's substitute this. Now here we have that 4 is equal to 4 to power t over 3. So 4 raised to power 1, 4 is raised to power 1, and since the bases are common, that is a to power n, this is equal to a to power m. Since the bases are common, then the exponent n is equal to m. So applying this property, then you find that here we'll have 1 is equal to t over 3. So to solve for t, we multiply both signs by 3. So that means that t is equal to 3. T is equal to 3. Okay? Let's check for y. Y here is 3. So we'll have 3 to power t over 3. This is equal to 3. The bases are common here. So this is 3 to power 1. Since the bases are common, then we equate the powers. That is t over 3. This is equal to 1. So let's multiply here by 3 and also here by 3. So this implies that t is equal to 3. So that implies that the first set of solution, x1, y1, which is 4, 3, actually satisfies the equation. This satisfies the equation. Okay? So the value of t here is 3. Let's check the second set of solution, x2, y2 here. From the second set of solution, x2, y2, which is 3, 4, and given that x is equal to 4 to power t over 3, and y is equal to 3 to power t over 3. Now, let's try to equate here. So x is 3, so we'll have 4 to power t over 3. This is equal to 3. 3 is raised to power 1. And for the case of y here, we have y equal to 4. This is equal to 3 to power t over 3. So as you can see here, the bases are not common here. Even for the second case here, the bases are not common. So this implies that here we have different bases. And this, because of difference in the bases here, we will not have no integer solution if we have to use this second set of solution. So this implies that we only have the only set of solution that satisfies the equation is x1, y1, which is here, which is 4, 3. And therefore, the value of t is equal to 3. The value of t is equal to 3. So let's verify here. Let's verify that this value of t satisfies the equation. Now, if you recall, we entered that is 4 to power t, plus 3 to power t. This should give us a value of 91. This should give us a value of 91, as you can see here. So substituting the value of t, which is 3, then this means that we have 4 to power 3 plus 3 to power 3. This should give us a value of 91. So 4 to power 3, this is the same thing as 4 times 4 times 4, and this is equal to 64. 3 to power 3, this is the same thing as 3 times 3 times 3. 3 times 3 is 9 times 3, 27. So we have 64 plus 27. 7 plus 4, this is 11. 1 carry 1 here. 6 plus 2 is 8 plus 1, 9. So it's clear that we have that the left hand side is equal to the right hand side. Okay? And this implies that the value of t, which is equal to 3, satisfies the equation. So kindly follow the steps, like this video, and subscribe. See you in the next video. Bye bye.